This is the nature of things. The Earth is home to a wonderful diversity of living things. Sometimes they can seem completely alien, at other times like a reflection of ourselves. Is it possible that these creatures really feel emotions like ours? That they love and hope? That they think? The latest research into the inner lives of our fellow animals is transforming how we see them, and even how we see ourselves. What pet owner doesn't think their dog or cat has feelings? But while happiness or fear are obvious, what about emotions like hope or compassion? And what happens if your pet is a ferret or a spider? Can we ever know how animals experience the world? People have always been drawn to and repelled by these animals that look so much like a distorted version of what we see every day in the mirror. We seem so much alike. No wonder they make us laugh or cringe. But that's a long way from believing that they are like us, with emotions, thoughts, and even morality. And if that's hard to believe of our fellow primates, what are we to make of creatures that look and behave even less like us? Here at the edge of the Winnipeg Zoo is a hidden warren of shared tunnels, home to a colony of Richardson's ground squirrels. They compete fiercely for food and mates. But they also cooperate, sounding a warning at the approach of any possible danger. Professor James Hare of the University of Manitoba has spent many years observing, recording, and testing them. He's come to believe that their system of communication reveals that even these rodents have complex inner lives.
So if we're able to decipher the information within a given animal signal, we find out what it is they're attending to in their environment. It gives us, if you will, a window into the mind of those non-human animals.
Decoding their communications reveals that ground squirrels have more going on in their heads than you might imagine. They signal to let others know, not just that a potential predator is approaching, but whether it's an airborne or ground attack. And they share even more information than that.
They know if it's Joe or Bob or Ted, whichever other squirrel it is that's calling, they recognize the caller.
Not only are they able to tell who's who, but they're also able to make complex social judgments and figure out how much they can trust the warning signals of specific individuals.
These squirrels have in effect evolved what we could call a concept of reliability. They have a mental representation of those individuals as callers and are associating that with their past performance, their past reliability.
Animals with concepts and mental representations, with emotions and thoughts, with inner lives like ours. Only a few years ago, claims like that would have seemed outrageous.
When I started as an undergrad studying animal behavior, I was told that things like anthropomorphism, where we ascribe human attributes to non-human animals, and in particular things like emotion, was totally taboo. In effect, there's been a revolution in the way we think about animal behavior.
Generations of scientists were taught that you couldn't know anything about what was going on inside an animal. They were to be considered like a black box you couldn't open. All you could ever know was the stimulus going into the black box and the behavior coming out. Not many years ago, resistance to that idea made Frans de Waal something of a maverick. Today, he's widely respected as one of the world's foremost authorities on animal behavior.
I grew up as a graduate student under that taboo, is that you never talk about animal emotions because the black box is sacred and we cannot look in the black box. And I've always objected to that because I think it's very obvious that animals have emotions, but that was the rule of the day.
More than anyone, it's researchers delving into the workings of the brain who are challenging the old orthodoxy.
For example, there's no part in the human brain that is not present in a monkey brain.
And we share much of our brain structure with other animals, not just monkeys.
If you remove the amygdala of a rat or you stimulate the amygdala of a rat, it has repercussions for fear. And so they're saying the human brain and the rat brain have similar emotional centers, similar emotional areas. And so they're basically breaking open the black box and saying the emotional life of humans and rats is not particularly different brain-wise. And so they have broken open that taboo. And so the taboo that we are not allowed to talk about emotions is completely disappearing at the moment.
For Professor de Waal, these new insights of brain science have far-reaching implications.
So if, let's say, two chimpanzees kiss and embrace after a fight, which I call a reconciliation, and humans kiss and embrace after a fight, which we call a reconciliation, I'm going to assume that the psychology of those two behaviors is very similar. And the burden of proof, for someone who wants to say, well, in humans there must be something else than in chimpanzees, the burden of proof is on that person to prove to me that what humans do is different. And I've never seen that kind of proof.
And proof of what's going on in another animal's head is difficult to come by when you can't just say, hey you, what are you thinking? But that's the same problem scientists face when they want to understand the inner lives of human children that have not yet learned to speak. To bypass the issue of language, they might, for example, give them a simple test and present them with two different objects. If the infant spends more time staring at one than the other, it seems to indicate a preference. Using these and similar techniques, researchers are able to gain insights into the child's perceptions, all without asking them a direct question. They apply the same kinds of tests to other animals. It can be a bit like trying to read someone's mind or like decoding a secret message. We judge other animals much as we do other people. If they understand what we want, they're smart. If they do what we want, even better. But is being trainable the same thing as being smart? Or will we discover that even animals who are difficult to train can show remarkable intelligence? Consider the example of these lemurs. Outside of their home in the jungles of Madagascar, the largest group of lemurs in the world lives here, in these North Carolina woods. It's surprising how much we have in common, considering that lemurs, monkeys, and apes last shared a common ancestor some 75 million years ago. Now our distant relatives are helping us to understand how the human mind evolved. And in Professor Elizabeth Brannon's lab, they're revealing surprising abilities.
Licinius's job is to look at these two images on the screen and figure out which one has the larger number of dots in it. So obviously, if I gave you this task, I could just tell you, well, choose the array with the larger number. But I can't do that with Licinius. And so we have to figure out how to train him on what the task is. When he makes a correct response, he gets a little fruit-flavored pellet, sugar pellet, that is automatically delivered by the computer right below the screen. And when he makes an incorrect response, the screen just turns black. And by that kind of feedback, he can, by trial and error, figure out what his job is. With young babies, we use very different methods to try to gain insight into their minds. Once we get to about 3 years old, we can get kids to use the touchscreen pretty well, just like we can do with a monkey or a lemur. And we find that 3 and 4-year-olds, in general, on average, their sensitivity is probably a little bit less than macaques and lemurs. And not until they're about 4.5 and 5 are they really surpassing the monkeys and the lemurs.
Some might say that it's one thing for an animal to have an elementary grasp of numbers, but it's quite another for them to use that to solve a puzzle, to think things through, to figure things out. But there's a puzzle for scientists: how to pose the question in a manner that allows the animal to respond in a meaningful way. And that will vary with each species. For example, there is no animal whose history has been intertwined with ours longer than the dog. Domestication has prepared them, in sometimes surprising ways, to understand us. The left side of our brain deals with emotions. It also controls the right side of our face. Experiments reveal that when we first encounter someone, our eyes, without conscious effort or awareness, focus on the right side of their face, the side that may better reveal the other's emotions. And dogs, along with rhesus monkeys, are the only other animals we know of that do the same thing. When they see a human, they automatically focus on the right side of the person's face. Perhaps it's no surprise then that dogs have actually evolved to understand humans, that they are biologically programmed to read us. So, how much of what a dog learns is simply instinct or conditioning, and how much is a sign of intelligence? Can Napoleon here understand that a pointing finger is meant to help him locate the hidden treat? This experiment is aimed at finding out, but that means the researchers have to make sure he isn't getting additional clues, like the smell of the food.
So the reason we're interested in the pointing is because we know that in using social information in our own lives, that this is really important for us becoming human. And when I say us becoming human, I mean from an evolutionary perspective, but I also mean from a developmental perspective. And so one of the ideas is the reason we develop into the humans that are cultural and linguistic and we have so many other sophisticated abilities is because at a very young age, we start really keying in to the social information that others provide us.
It may seem natural for a dog, just like a child, to pick up on the meaning of our gestures. But that's exactly the point. If it's so obvious, shouldn't our closest relatives be better than a dog at decoding our signals?
The first thing we did is we looked at non-human primates, bonobos and chimpanzees, in particular. And it ends up that they're not particularly flexible at using social cues, particularly when it's a human. So if a human tries to tell them where something's hidden, they're not very good at it.
At the Chimpunga Chimp Sanctuary in the Republic of Congo, a chimp is brought into the testing area from his outdoor home. The question is posed. But the pointing finger doesn't seem to be of much help.
But if we look at dogs, it ends up that dogs are incredibly flexible at using human social cues.
A dog can understand human signals that are even more subtle than a pointing finger.
We'll even put a novel marker that's arbitrary. Let's say we take a block and we put it on top of where the food is. That's not something you do with your dog normally. And the question is, does your dog still understand what that means?
This is much more than Napoleon being conditioned to follow the stimulus of a pointing finger. What we're seeing here is something completely new for him. This is the very first time his clue was a marker placed on the cup.
Good boy. Yeah, good boy.
Napoleon understands that he's being helped, and he can correctly interpret even this totally novel signal. It looks like dogs might understand us better than we understand them.
There you go. Good boy.
So where's the dividing line between humans and other animals? How smart are they, really? Elephants have been used in Asia for transportation as well as heavy lifting since ancient times. They have a reputation as clever animals for never forgetting. But can they really think? Scientists Dr. Diana Reiss and Preston Forder are exploring exactly this question. Today they are trying to determine whether elephants are capable of insightful problem solving, whether they have aha moments.
And the bamboo's in position now. The idea of insightful problem solving is that you're presented with a problem, you don't show trial and error trying to figure it out. You may look at it for a while, you may go away from it for a week, and then suddenly the problem is solved. You come up with that novel solution.
Just like today, 2 years ago they tested this elephant by dangling a tender bamboo branch with fruit hanging from it just out of his reach. It was left hanging for 20 minutes each day, and for 6 days he spent most of that time just staring at it. Then everything changed.
On the 7th day, the elephant tried to reach for it, and he couldn't get it, and he walked over to a cube that was in there. And he rolled the cube back, and underneath this food. Stood right up on the cube and reached for the food. It was, boom, he figured it out, just like that. It was that instantaneous moment that's talked about as insight.
Now he faces the same test, but 2 years have passed, and his enclosure has been totally changed around.
And there he goes.
He's highly motivated right now.
So the question is, will he remember?
And it doesn't take long to get the answer. He knows just what he needs, and he doesn't hesitate.
And he remembers.
Look at that. He went right for the cube. New habitat. They say elephants never forget.
It's been 2 years since he did this. 2 years.
And then, something even more astonishing. When the cube is removed, he sets about looking for something else that will do the trick.
this big tree trunk he's pushing now. This is something that he hadn't had before.
Stick. Nope.
A little piece of log, and he stands on the little log. This is great.
Uh-oh. The cylinder is not quite good enough for his weight.
He's putting his foot up on the tire. He's got his trunk and his foot on the tire.
And despite all the changes, he can find the tool he needs in order to rise to the challenge. But is the ability to think out solutions to new problems presented by a changing environment only something these notoriously brainy animals can do?
It's not always going to be found in really big brains. We can see very small-brained animals are quite capable of doing some pretty complex thinking.
We tend to assume that these anolis lizards, like other reptiles, have limited brain power and relatively fixed behaviors. But here at Duke University, Professor Manuel Leal has shown that these lizards have more going on than we ever imagined.
We know a lot about things like birds and mammals, but we know very little about lizards. So we designed a relatively simple experiment. And the experiment simple, in which we use a piece of wood in which we drain 2 holes, and one of these holes was charged with a worm.
After the worm is placed in one of the holes, they are plugged with brightly colored covers. The next step is to make sure that color is the only clue to where the prize is hidden.
And once they make a decision, they will flip either this disc or that disc. If they flip the correct disc, then they actually get a worm.
Their first challenge is to learn to hunt in these unusual conditions. Once they've mastered this winning strategy, they'll tend to go directly for the correct color. But what happens when the rules change? Can the lizard adapt?
Once they seem to have developed an association with a given color, then we trick them. So now the one that used to have a worm doesn't have a worm anymore, and the one that was previously empty now has a worm. This is what is called reversal learning. So we're asking the lizard, can you reverse your previous association?
Where once they always went to yellow, for example, now they'll reverse that and favor blue.
And it turns out that, yes, lizards can reverse learn. It's just demonstrate the ability to create new associations, break an old one and have a new one. And this ability suggests that there is a flexibility. It's not completely sort of fixed.
Not only were they able to get the worm in this artificial fashion, but they were also able to remember their strategies and adapt them to a changing environment. It wouldn't be too impressive if your dog or cat managed that, even your pet budgie, but it goes well beyond what we thought lizards could do. And that's far from the most surprising thing we're discovering about the inner lives of other animals.
What we're putting in here is it's a maze. It's designed to simulate foraging behavior that the animal would experience in the wild. They're very intelligent animals, I've found, that they're very good problem solvers. The first time I ever gave him the maze, he actually solved it within 5 minutes of it being dropped in. So it was a little frustrating for me because I built this, I spent about 45 minutes putting this together, and he solved it instantly. Exactly. We have a jar.
Jennifer Mather of the University of Lethbridge is visiting the Baltimore Aquarium, comparing notes with Morgan Denny, keeper of the giant Pacific octopus, a creature Professor Mather has studied for years.
What's fascinating about octopuses is they're smart, and they're not just smart, they're different from us smart. So when we study the evolution of intelligence, lots of times we'll say, well, everything is working towards this peak, which is us, which is maybe a little bit unfair, but the octopuses are a different root. They're not related to us at all. So that gives us a chance to say, well, what's intelligence really like, not just with us, the vertebrate model, but with a different model. And that's what I find fascinating.
These creatures are so different from us that it makes it difficult to even begin figuring out how smart they might be. Professor Mather thinks that traditional lab tests are not the way to go.
Unfortunately, when we test them, sometimes we give them very simple tests. So we give them a jar, we go, gee, they can open a jar.
While this may seem impressive to many of us, Professor Mather says it's just one example of how we underestimate them. Another is this kind of simple maze, where the challenge is to get to the food.
We give them what you call a T-maze, where they come and make a choice to go there or there, given whether there's a visual stimulus here or here, and we go, gee, they can go left. One of the things I've been trying to do is to look past this and to look at different things that indicate more about what their capacity is.
And this capacity may be best demonstrated in their natural habitat. And that's precisely where we find one of the most remarkable examples. One which places the octopus in the very select ranks of tool-using animals. It's not unusual for an octopus to shelter in a cave or shell. That's not something most of us would consider tool use. But these octopus pick up shells and carry them around in case they need shelter from a predator. Much like someone might carry an umbrella anticipating rain. It seems that they can use tools and plan for an uncertain future. But the big question remains, are they aware of themselves? Perhaps that's hard to believe of invertebrates like the octopus. After all, they're more closely related to slugs or snails than they are to humans.
Are you guys ready for a great dolphin show?
In evolutionary terms, our closest relatives are our fellow primates. But primates aren't the only almost hairless, big-brained mammal on this planet. Whales and dolphins are right up there.
What we're interested in is understanding their kind of intelligence, the nature of their intelligence. What are they doing with these big brains?
One way Reiss and her colleagues have of probing that question is by studying dolphin communication. What do their sounds signify? How many of these sounds are just random?
And those are whistles. They make a large variety of sounds.
Do they signal general situations, one call meaning danger, another meaning I'm happy, or are they more specific? But even the simplest animals signal each other. Even plants send out chemical communications. Now, cutting-edge research is trying to reveal whether these animals are conscious, are aware of themselves. Many researchers felt that was a riddle with no answer. Then scientists figured out how a very mundane object might hold the key.
Now the question is of consciousness. It gets really tough. So how do we start asking these questions? And one of the ways that I've been looking at this is through a looking glass or a mirror.
The one-way mirror placed in the window of this underwater observation room lets them watch their subjects while the dolphins just see their own reflections. The mirror test asks the question, can these animals recognize themselves in a mirror? Sounds simple, but dogs can't do it, and cats can't do it. Even young human children can't do it. The first non-humans to pass the mirror test were our closest cousins, the other great apes. Then elephants and dolphins, whales, and at least one kind of bird, the European magpie, joined this select group. Just like with a human child, at first the dolphin doesn't know it's looking at itself.
So mirror self-recognition is first shown in humans at about 18 to 24 months of age, year and a half to 2 years. Chimps seem to show it at about 4.5 years of age. I think there was one chimp that showed it at about 2.5. What about dolphins? So again, we're not finished the full analysis yet, but it's much earlier than we thought. What we're finding is that dolphins show 3 stages of behavior in front of a mirror. If they've never seen a mirror before, they try to look behind the mirror. They try to look over it. They may show social behavior. Then they show a second stage. And it's that second stage where they really seem to learn that it's themselves in a mirror, that what they're doing is matched by what they see in the mirror. And then we see this third stage, which is called self-directed behavior. And that's where they look at parts of their body that they simply have never seen before. They look at their eyes closely. They'll hold their eye right up against the mirror and look.
And again, this is what we see with, look at that, looking right at their eye. That's perfect.
They might look at their eyes, or they might examine the inside of their mouths.
Do you think she's looking at her teeth? And
I think she's just looking at the inside of her mouth like we see with the other animals too.
They might look at a part of their body they can't normally observe, or at something they often do, but can otherwise never see.
Bubble burst. Wide open mouth.
Dolphins are very vocal creatures. They make sounds to help them to see and to communicate. That gives another clue to what is going on, since once they get the idea that they are seeing themselves in the mirror, they are absolutely silent.
yeah, she's really looking.
And they're completely quiet again.
And they're not making any sounds. Look at her eye moving around.
So it's quite fascinating to see dolphins doing these, again, these 3 stages, because humans show those stages, and so do chimps, and elephants do. Now, dolphins are not humans, okay? But they're beings. There's somebody in there. There's somebody in there.
Some people find the idea of thinking, feeling, self-aware beings that aren't human very disturbing. Others think that it's only natural. But what if, on top of all that, we aren't the only creatures with a sense of right and wrong? It seems that we are not the only rational animal, much less the only one with feelings. But even those who are comfortable with losing our monopoly on these features may find it difficult to admit that we are not the only animal with a sense of justice, with a sense of fair play.
I talk a lot about morality in animals, the origins of morality. When I talk about that, people sometimes say, well, if there's continuity with respect to morality, then what is the difference? So they're sort of disturbed by how much continuity I see there is between the great apes and humans, because they want to cling to the idea that we are absolutely unique. Now, I think we humans are unique, but the word absolutely is what I have trouble with. We did an experiment on fairness. What we would do is we would put 2 monkeys side by side, and they would get rewarded for a very simple task. If you give both monkeys the same reward, they're perfectly happy.
Once in the testing area, the monkeys are given a small token. If they're willing to return it, they get a treat. But when, for example, the monkey on the right is given a sweet grape and the one on the left just gets a cucumber, things immediately get dramatic.
And so that's a sense of fairness. We call it inequity aversion. And it's very similar to what you see in young children. Now, you could argue that for a full-blown sense of fairness, the one who gets the grapes also needs to be worried about it.
And that's just what they've found. Unlike those monkeys, chimps will go as far as refusing the grape, unless the other also gets one.
So now we have, in chimpanzees at least, we have a sense of fairness that goes so far that you sacrifice something for it. So I think the human sense of fairness is not absolutely unique. And when we react to the bonuses on Wall Street, for example, we're showing a sort of monkey reaction to somebody else getting something better that we're not getting.
Chimps may have a sense of fairness, but they are not all sweetness and light. Far from it. These chimps know Professor Brian Hare, and he knows something of their customs.
So it's a nice way to say hello, of course, because the wall is there between us. And, you know, in the wild, or if that wall was not there, then the display is actually a quite serious signal that I am a very big guy, and I'm tough, and don't mess with me.
Chimpanzees have a society where a small group of males use their strength to dominate the larger group. They are even more aggressive with strangers.
They also use aggression to even kill other individuals in neighboring groups and to try to take territory from neighboring groups. Sounds kind of familiar.
They have gotten the reputation of being aggressive, which came obviously from the field where male chimpanzees of different communities have fights and sometimes kill each other. And those males also sometimes kill infants. But humans, of course, have that same potential. We can be awfully aggressive and nasty, but we can be awfully nice and altruistic.
But even the potentially aggressive chimpanzee has been observed showing what we might call empathy. How to explore the limits of that social emotion requires some ingenuity.
We are interested in studying empathy in chimpanzees. Empathy, what we think of as feeling what someone else feels, what they're going through, their experiences, it's very difficult to measure.
What was needed was a simple test where the chimps' responses could be directly observed.
So I went up to the chimpanzees and I pretty much did this.
He simply showed the chimps videos of their fellow chimps yawning. The researchers thought that if they were right about empathy, the chimps would yawn more in response to the videos of chimps they knew than to those of strangers. And they were right. While the chimps appeared most interested in the strangers, they only yawned in response to members of their own group. And that seems to reflect the limits of their empathy. People don't respond quite the same way.
So you show volunteers a video of strange people yawning, and we yawn in response. Chimpanzees don't seem to do that. So I think one of the limits is, and one of the big differences in humans, at some point in human evolution, we gained the ability to tolerate people we don't know. We couldn't live in a city of 1 million people if we couldn't tolerate people we don't know. Chimpanzees haven't gotten to that point yet.
So what point have they got to? These chimps are certainly willing to let a friend dip into their food, up to a point. However, when it comes to how we treat each other, we have another relative that may very well put both chimps and us to shame.
We have two closest relatives. Many people don't know that. We have the very famous chimpanzee, and we have the less known bonobo. And we're equally closely related if you compare our genetics to both species. In bonobos, the world is very different. There, it is a more female-based society where males do not dominate the group. Males do not call the shots. And more than that, because males can't dominate females in the group, it also stops them from trying to kill and go into neighboring territories to take over everybody else's territory. So basically, bonobos don't have any of the dark side that you see in chimpanzees and perhaps in our own species.
So bonobos are sort of the hippies of the primate world. They're very peaceful, not always, but they're quite peaceful and sexy. So, for example, bonobo groups, when they meet, there is some hostility, but very soon they have sex with each other and then they groom each other, and it actually looks more like a picnic than like a war as it does in chimpanzees. Chimpanzees never have friendly, as far as we know, they never have friendly relations between groups.
So we know chimps will cooperate and even share with a friend, but never with a stranger. Bonobos, however, will go much further than that. At the Lolaya Bonobo Sanctuary in the Congo, Professor Hare and his colleagues have been able to explore the bonobo's generosity. This bonobo has been brought in from the jungle habitat where she spends most of her time. She's going to be offered some food and a chance to share it. It's a situation where a chimpanzee would simply eat the food itself. Not only is this bonobo quick to open the locked door to share it with a friend, she's just as quick to share it with a total stranger. But if bonobos and even chimps have empathy and a sense of fairness, if an octopus can use tools, and at least some of our fellow creatures are self-aware, where does that leave us?
We are definitely unique. We have language, we have symbolism. Our morality is way further evolved than what I see in chimpanzees. And so I see an enormous amount of gradual differences, some absolute differences, but to say that we are on a different planet, so to speak, we are the crown of creation and we're totally separate, that's not something I can support.
So the big picture is that we are not alone. We are not alone as intelligent creatures on this planet. We share many of our abilities with other animals. And each creature on this planet, us included, is beautifully adapted to fit their environment.
We also share a planet. Vanishing species, widespread habitat destruction, climate change. These are challenges that will affect not only humans, but other beings as well.
Indeed, in the end, I think accepting the possibility of consciousness and coming to a greater appreciation of other species is critical for our own survival. We have to learn ways to deal with the rest of the world in a better way if we're going to survive ourselves.